Hello, my dear boys. Hope all of you are well by the grace of Almighty. Good morning, everyone, and welcome all of you to my online physics class. We are starting chapter 10. The name of this chapter is Static Electricity, and today we will also try to solve another creative question. Okay, so let's boys, firstly we will see our today's creative question. My dear boys, this is our today's sample creative question. Here, this is the stem of this creative question. Here, we have two sphere of same radius is 5 centimeter. Okay, this the charge of this sphere is plus 30 coulomb and the charge of this sphere is minus 10 coulomb. Okay, and the surface to surface distance between these two sphere is 2 meter. Okay, this 2 meter is surface to surface distance. You must be careful about this distance. Okay, here the 2 meter is surface to surface distance, but when we will solve this question, but we need to solve this question the distance between the center to center. Center to center, we use the distance for center to center. Okay, so this is the stem of this creative question, and the questions are: what is called static current? This is our question A. Question A is what is called static current. Question B, here is the statement: electric lines of force are upward or outward for positive charge. Explain. Okay. Question C is find out the force between two charges. Okay, and question D is electric intensity will be 0 at a certain distance from the small charge. Examine with mathematical logic. My dear boys, this is our today's sample creative question. Okay, now we will try to solve this question step by step. So, my dear boys, our question A is what is called static current? The answer is static current means the increase of electric charge on the surface of objects. Okay, this electric charge remains on an object until it either flows into the ground or loses its charge quickly by a discharge. Okay, so my dear boys, I am repeat it again. Static current means the increase of electric charge on the surface of objects. Okay, this electric charge remains on an object until it either flows into the ground or loses its charge quickly by a discharge. My dear boys, our question B is electric lines of force are outwards for positive charge. Explain. Okay, so the explanation is an electric line of force is an imaginary continuous line. It has no physical existence. Only as a field it exists. The direction of a line of force is defined as the direction along which a small free positive charge will move along the line. In this way, it repels from the positive charge. Okay. In this way, it repels from the positive charge. So, electric lines of force are outward for positive charge you see in the figure. Okay. So, electric lines of force are outwards for positive charge. My dear boys, now we will try to solve question number C. Okay. Here our question is find out the force between two charges. Okay. Here this is our stem. From this stem we have given that charge Q1 equal to plus 30 coulomb, charge Q2 equal to minus 10 coulomb. Okay. Distance D, here this distance is surface to surface distance. Okay. So, distance D equal to 2 meter, but we have given the radius of these spheres, and we know that for this calculation we need the distance between the two surfaces center to center. To get our center to center, we must add this surface, this radius and this radius. Okay. So, center to center distance will be r equal to 2. Here 2 is surface to surface distance and this 2 is 0.05 is the 0.05 plus 0.05. Here 0.05 is the radius of the 0.05 meter here. Here we have given in centimeter unit, but here we put the value in SI unit. Okay. So, here center to center distance will be 2 plus 0.5 radius. We should add radius and radius of these two surface. Okay. So, total distance r equal to 2 plus 0.05 meter plus 0.05 meter. So, we get 2.1 meter, and here we need to determine the force between these two charges F equal to what. Okay. So, we know from the formula of static force or Coulomb force, F equal to K into Q1 Q2 divided by R square. Okay. Here K is a constant. Here K is called Coulomb constant. The value of this constant is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay. So, putting the value of this parameter and after calculating we get F equal to minus 6.122 into 10 to the power 11 Newton. Here we get the charge as force with negative sign. Okay. Here negative sign means that the force between these two charges is attractive. Okay. I am repeating it again, and the negative sign, negative sign of this force, means that the force is attractive. Okay, the force is attractive. So, we can write that the attractive force between two charges is 6.122 into 10 to the power 11 Newton. Okay. So, my dear boys, this is the solution for question number C. My dear boys, now we will try to solve question number D. Here our question is electric intensity will be 0 at a certain distance from the small charge. Okay, examine with mathematical logic. Okay, here we have, this is our moderate figure. Here the smallest charge is minus 10 coulomb. Okay, so our neutral point or electric intensity will be 0 from the outward of this charge. Okay, or we can say that the electric field intensity will be 0 from the opposite of the charge, opposite side of the charge or greater charge. Okay, so here we assume that, assuming net electric field is 0 at a distance x from minus 10 coulomb to the direction opposite to 30 coulomb. Okay, so at point P, net electric field intensity is 0. So we can write E2 equal to E1. So we can write K into Q2 by x square. Here the distance from Q2 to P is x, and here the distance from Q1 to P is 2.1 plus x meter. Okay, so we can write K into Q2 by x square equal to K into Q1 by 2.1 plus x whole square. So here K and K is cancelled, and after calculating we get the value of x is 2.869 meter. Okay, so here x means the distance from the smaller source or minus 10 coulomb. Okay, here the distance is 2.869 meter. Okay, but from Q this distance is more than this, more than or greater than this distance. Okay, so we can say that electric intensity will be 0 at a certain distance from the small charge. Okay, so at 2.869 meter away from charge minus 10 coulomb, the electric field will be 0. Okay, so my dear boys, this is all for today. In our next lecture, from this our syllabus is end from this chapter. Okay, so in our next classes we will try to revise our third term syllabus. Okay, so my dear boys, until then, thank you.